Hi, I'm Romina Percy and welcome back to Earth from Space. Today the Copernicus Sentinel-1 mission takes us over Crete, Greece's largest and most populous island. The two identical Copernicus Sentinel-1 satellites carry radar instruments which can see through clouds and rain, and in the dark, to image Earth's surface below. The sea's surface reflects the radar signal away from the satellite, making water appear dark in the image, while cities on the island are visible in white, owing to the strong reflection of the radar signal. Crete extends for approximately 260 kilometers from west to east, and is approximately 60 kilometers across at its widest point. Crete is known for its rugged terrain, and is dominated by a high mountain range crossing from west to east. This includes the Lefka Ori, or White Mountains in the west, Mount Ida, Crete's highest mountain, visible in the center of the image, and the Dikti Mountains in the east. Crete's capital and largest city of the island, Heraklion, is located along the northern coastline. Several other smaller islands are dotted around the image, including Gavdos, Krisi, and Dia. Unbeknown to many, the island of Crete plays an important role in the Copernicus satellite altimetry constellation and on an international stage. Satellite altimetry data have to be continuously monitored at ESA's permanent facility for altimetry calibration, where different techniques have pioneered the use of transponded. These are linked to international metrology standards to provide the best measurements to validate satellite altimeters in space soon after launch. This network has been operating for around 2 decades, with the main calibration validation station located on the island of Gavdos, and a dedicated transponder site in the Cretan Mountains. A transponder receives, amplifies, and retransmits the radar pulse back to the radar altimeter in space, where the signal is recorded. Western Crete was identified as a unique location for the intercomparison of satellite altimeters, owing to its unique positioning of the Copernicus Sentinel-3 and Sentinel-6 orbit crossing points. The sea surrounding the island has minimal tides, and the rugged mountainous landscape means that the transponder signals can be measured from space with little interference. But most importantly, in the sky above it, a number of satellites in orbit converge. This allows each satellite flying above to be cross-calibrated with the next one at one specific meeting point using the same instrumentation. The fiducial reference measurements for Sentinel-6 is the latest activity designed to bring the full power of the permanent facility altimetry calibration to check the performance of the upcoming Copernicus Sentinel-6 Michael Freilich satellite, the next radar altimetry reference mission, extending the legacy of sea surface height measurements until at least 2030. Every 10 days, Sentinel-6 will provide sufficient measurements to map the sea surface height of the ocean from which sea level rise can be computed. As part of ESA's contribution to the long-term verification and validation of both Sentinel-3 and Sentinel-6 missions, the permanent facility altimetry calibration is being extended with a second transponder to be installed on Gavdos Island, southwest of Crete, as seen in this Sentinel-1 radar image. This will give the big picture, allowing us to chart the sea level with confidence. And that brings us to the end of this edition. Don't forget to like and subscribe to the European Space Agency channel. I'm Romina Percy from ESA Web TV Studios. Thank you for watching.